Welcome to September 23rd's LeetCode Challenge. Break a palindrome. Given a palindrome string of lowercase English letters palindrome, replace exactly one character with any lowercase English letters so that the resulting string is not a palindrome and that it is the lexicographically smallest one possible. Return a resulting string if there's no way to replace the characters to make not a palindrome. Return an empty string. A string A is lexicographically smaller than a string B of the same length if the first position where A and B differ, as A is a character strictly smaller than corresponding character of B. For example, we have the string ABCC is lexicographically smaller than ABCD because the first position they differ by the fourth character, which is C, which is smaller than D. That kind of makes sense in its own example. So we're given this a string of palindromes here. We have basically A, B, C, C, B, A, and this palindrome. We want to be able to break that up and what is the first letter we're going to replace with, let's say, an A that makes it not a palindrome before. So we want to start with a lexicographically smaller letter and then work our way up as we break up the palindrome, right? So we're going to put into replacing B with A, which is lexicographically because B is smaller than A, which makes it smaller lexicographically, and also we break up the palindrome. So there's many ways to make A, B, C, C, B, A not a palindrome, such as inserting Z or whatever, right? But we want to be the lexicographically smallest. So if we have a single letter, for example, we have A. Well, there's nothing, we can't replace A with anything lexicographically smaller, so therefore we need to return, if there's no way to replace a smaller character, return an empty string, which is returning. And then we have the palindrome here, A. So we notice how we return the second character into B, right? Ideally, we could actually make this character to B as well, but we want it to have, for instance, the lexicographically smaller, meaning the last character should be the smallest one, right? Or the difference-wise, compared to the original. And likewise, same thing deal here. We make the last character A into B because we can't really go smaller than A, so therefore we need to go B, right? And it's kind of, this example is kind of showing like what's called a greedy type approach to it. just from looking at these two examples, the last two examples here. Palindrome length constraints of palindrome length being 1 to 1,000, and palindrome consists of only English lowercase letters. Okay, let's look at some examples here. It is impossible to perform a replacement algorithm of only length size 1. How do we check that? So it's asking about our base case. So basically, if n equals 1 or the length of size 1 is equal to 1, we return the length of 0. Let's just write that in right now. So n equals length of palindrome. Let's see, if n equals 1, return an empty string. That's pretty much that out of the way. Change first character, non-A character to character A. How do we know when to do that, right? We need to do it. What if the character only has A? So what do? We just return an empty string. So that's not a big deal. And change last character to B. So this actually telling you the kind of approach to it, but let's just see where it goes. And alright. So let's iterate through palindromes. Since it's a palindrome, we only need to iterate through it for each element index in the range. So since it's a palindrome, we only need to iterate through half the time. Not half, but halfway. So let's see, if it's even palindrome, it's an integer division. If it's odd palindrome, it's also going to be an integer division, right? We can't have half letter, so we're going to do an integer division by half here, or floor division, I mean. So if palindrome at index I is not equal to A, because what do we do if the first non-character is not an A, or any character is not an A, right? We are basically going to return the following. So we want the palindrome, basically we want to break it at that index. So palindrome at that index from the beginning to I, we want to do our best to add an A to it if it's not A character. And we're just gonna do a concatenation here, palindrome. And obviously we're taking index I out of it if this is index I. We need to basically concatenate with the ending of it, so it'll be I plus 1 to the very end. Oops, very end. So that's what we want to return if the middle of the palindrome is not an A, or if index I is not an A, I should say. And then we return that if it is not an A. Else, else we just return basically the letter. If the string only has A, return empty, as we would do here, because we just turn A back. I mean, I can write another base case for it, but it's whatever. Change the last character to B. We're going to do that now. So palindrome basically to the very last character and change it to a B, which will be make it the most lexicographically smallest. All right, let's run the code. And the reason why we deal with A and B only is because if it can't be A, the next palindrome spelled that wrong. If it lexicographically can't be A, the next smallest lexicographically letter is B. So that's why we only deal with A and B. And it looks correct. Alright, awesome. So, I mean, a couple things we should know in terms of the conditions here. The length of the string is 1, then we just return the empty string, as we did. If in the first half the letter, other than A, is there, we can replace it with an A, right? And return the whole string as concatenation. Else, if all the letters are A in the beginning half, then we just return the string, the last letter replacing A with B, essentially. And in terms of time complexity, we have a for loop here, so it'll be big O of n for time complexity, and space complexity is big O of n as well, because we need to basically store each character. We store each character inside the array. Hence, space complexity is big O of n. But this is a greedy. This seems like a very greedy like approach algorithm. So that's it. Have a great day, guys.